Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the 7th question from the mid-year examination which was written in the province of KwaZulu-Natal in the year of 2024. And please guys, do expect a total number of 10 videos since the question paper had 10 questions in total. That means each and every question will have its own video. And most importantly guys, please do take this seriously, because knowing how to tackle exam questions will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly your final examination. So guys, please do share the video to your peers as well so that they may have the same edge, né? And guys, please I beg you, please do help us grow the channel by just subscribing. Okay, we are given f of x, né? We are supposed to determine the derivative of f from first principle. There is an equation that guys help us to find the derivative from first principle, right? It simply says f prime of x, the derivative of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Are you together? Since we are given our f of x as 2x squared plus 4, it simply means that our f of x plus h will simply be 2 multiplied by x plus h squared plus 4. This will be f of x plus h. Are you together? And then let's just substitute to find our derivative. Limit as h approaches 0 of f of x plus h minus f of x, which is just 2x squared plus 4 all over h. The whole purpose guys of finding the derivative from first principle is to just substitute 0 whenever you come across h. But right now we cannot do that because we have an h at the denominator, and if you substitute 0 as if you substitute h as 0, the entire expression will be undefined because 0 will be at the denominator. So our main purpose right now is to eliminate that h over there before we substitute, né? Okay, limit as h approaches 0. Now you can guys simplify. You can open two brackets over there and multiply them out. You'll end up having 2x squared plus 4xh plus 2h squared plus 4 minus our f of x, which will lead us into negative 2x squared and minus 4. This entire thing is divided by h. Limits as h approaches 0. The 2x squared will just subtract one another. The 4s will just subtract one another as well. And then I'll be left with 4xh plus 2h squared all over h. Limits as h approaches 0. I can take out a common factor over there, which is h. Then I'll be left with 4x plus 2h all over h. Now I can remove the h at the denominator because they'll just cancel one another. I'll end up having limit as h approaches 0 of 4x plus 2h. Now I can substitute 0 whenever I come across h. And please note that guys, whenever I substitute, I no longer write the statement that says limit as h approaches 0. I'll simply substitute 4x plus 2 times 0. This will be equal to 4x. So I now know that my derivative will simply be equal to 4x. Will simply be equal to 4x, right? Okay, and then we are told that a tangent to the graph of f has a gradient of negative 12. Determine the equation of that tangent. For us guys to determine the equation of a tangent, we need both the gradient and any point that exists on our tangent. Are you together? But since we have a gradient, remember that guys, by definition, the derivative of a curve is always equal to the gradient of a tangent at a specific point. Are you together? The derivative of a curve is always equal to the gradient of the tangent at a specific point. Okay, So I know that's okay. My tangent has a gradient of negative 12. I want to know at which point is my gradient equal to negative 12. So what I'll do is to say f prime of x, which is equal to 4x. I want to know at which x value is my gradient equal to 4x. I can divide both sides by 4, then x will simply be equal to negative 3. I now know that the x coordinate of the point is negative 3. For me to find the corresponding y value, I just need to substitute the negative 3 over there. All right, together, I'll simply say f of negative 3 is equal to 2 times negative 3 squared plus 4. That's 9 times 2, that's 18, that's 22. So the gradient of my tangent at this point is equal to 12. So now I can find the equation of that specific tangent of mine. I can use the equation that says y is equal to mx plus c, then substitute the gradient and then go and find the y-intercept, or I can simply say y minus y1 is equal to mx minus x1, right? Y1 is equal to 22, m, that's negative 12, x minus x1 is just equal to negative 3. I still have y minus 22 is equal to 12, I have x plus 3. Now I can remove the brackets. Y minus 22 is equal to negative 12x minus 36. Then y is equal to negative 12x, negative 36 plus 22. This will simply give us a negative 14. So the equation of our tangent that has a gradient of negative 12 is simply equal. Is simply y is equal to negative 12x minus 14. That's the equation of our tangent. Okay, and then now, guys, we are told to determine the following. 7.2.1. I'm supposed to find the derivative of the function of x. But before I find my derivative, guys, there are steps that needs to be followed. Firstly, I must remove the sets if I have them. I must remove the variable I'm supposed to derive at the denominator. And secondly, I must remove brackets. And thirdly, rather, I must remove brackets. So if I have any one of these three problems, I must always remove them before finding the derivative. Whenever, guys, I find my derivative, I'll simply use the rule that simply says if g of x is equal to a x to the power n, therefore the derivative of g of x will simply be n multiplied by a, and then to the multiplied by x to the n minus 1. Just take the coefficient, just take the exponent rather, multiply it to the coefficient, and then subtract 1 on the exponent. Okay, this is the rule that, guys, you are supposed to use, but you must use this rule after we have eliminated our problems. Our problems, let me repeat them. If ever we have the variable we are supposed to derive in set form, we are supposed to make sure that we remove it from its set form. If ever we have the variable we are supposed to derive at the denominator, we must make sure we remove it by all means necessary. If ever we have the variable we are supposed to derive inside the bracket, we must make sure we remove it. Okay, number 1. We have f of x being equal to 2x squared minus 5x minus 12 is equal to x minus 4. Right, together. The only way, guys, to remove this guy over there is if we factorize our numerator. We have f of x, and please note that, guys, I'm not writing f prime of x. I will only have a right to write f prime of x whenever I'm finding my derivative. Right now I'm still simplifying. Okay, this thing is factorizable. I have x minus 4 over there, so this will be 2. I will have x, 4, and 3 over there. I'll have minus and plus. So f of x is basically equal to, these two guys will just cancel one another. Do you see that? The x minus 4. So I'll be just left with 2x plus 3. So therefore the derivative will be equal to 2. Are you together? Remember that, guys, the derivative of a constant is always equal to 0, né? So my derivative is just 2. The derivative of f is 2. Okay, and then now let's go and determine the expression on 7.2.2. We are given d of x, and then we have the fifth root of x squared plus x and x minus 9. This expression over here, guys, is the one that tells us to differentiate whatever that is inside the bracket. Are you together? And I'll keep writing it until I'm finding my derivative. Before deriving this expression, I should keep on writing dx. Are you together? So remember that, guys, I said to you, whenever I find my derivative, I must make sure the variable I want to derive is not in set form, and the variable is also not inside the brackets. So I have two of those problems. I have set form and brackets. So let us remove those. D of dx. There's a rule that, guys, in exponent that simply says that the root of a number is always the denominator of the exponent. So this can be written as x to the power b over a. Are you together? Same thing applies here. This is x to the power 2 over 5 plus x multiplied by x, that's basically x squared, x multiplied by negative 9, that's negative 9x. That's negative 9x, ne? And then now I can simplify my derivative. Why? Because I don't have brackets. And the variable I'm supposed to derive is not in set form. The variable I'm supposed to derive, it's not at the denominator as well. I can therefore find my derivative. Please note that, guys, whenever I'm finding my derivative, I'm no longer writing this notation over there, because this notation is the one that keeps on reminding me that I'm supposed to find the derivative. Are you together? So if my next step is the derivative, I'm not writing this thing. So the answer over here will simply be 2 over 5x. Then I'll simply subtract 1 from my exponent. I'll be left with negative 3 over 5 plus 2x minus 9. You can leave your answer like this, but if you want to be fancy, guys, you can make sure you leave it with positive exponents. Ne? You can leave it with a positive exponent. You'll simply have 2 all over 5 times x to the power 3 over 5 plus 2x minus 9. You can leave it like this, but if you want to be more fancy, you can leave your answer in set form. 2 over 5 the fifth roots of x cubed plus 2x minus 9. You can express your solution like this. This is fine, you'll get full marks. This is also fine, you'll get full marks, and that is also fine. Ne? But we are papa mawenza, so unless you are told to leave your answer in positive exponents. Ne? If you're not told to leave your answer in positive exponents, just leave it like this. Okay, now let's go to 7.2.3. We are given y, and we are supposed to find the derivative of y with respect to x. And please note that, guys, I will only write this notation whenever if and only if what appears on the right hand side of my equal sign is the derivative. Before finding the derivative, I'm not writing this thing. Right together. Okay. So y is equal to x over 6 minus 6 over x. The first thing I need to check, is the variable I'm supposed to derive at a denominator? Yes, it is. If it's there, I must remove it. There's a rule in exponents that says if you have c all over a to the power p, this thing can be written as c. This thing can be written as c multiplied by a to the power negative p. All right, together. Whenever you remove a term from the denominator, you must always guys change the sign of its exponent. Okay, over here, this can be written as 1, just to make things simple, as 1 over 6 multiplied by x minus 6 multiplied by x to the power negative 1. Are we together? Now I don't have, the variable I'm supposed to derive is not inside the brackets. The variable I'm supposed to derive is not at the denominator. The variable I'm supposed to derive is not inside the brackets. Now I can simply find my derivative. But whenever, guys, I'm writing my derivative, now I can simply say the derivative of y with respect to x is equal to 1 times 1 over 6. That's 1 over 6. And then I'll simply have x to the power 1 minus 1, which is x to the 0. Anything to the power of 0 is 1. So I don't need to write this thing. I'll simply have negative 1 over 6 plus 6 multiplied by x to the power negative 2. I can leave my answer like this, but if I wanted to leave it with positive exponents, I can simply express it like this. dy over dx is equal to 1 over 6 plus 6 all over x squared. That's how, guys, you're supposed to find your derivative. I really hope that, guys, the video helped you out. So please do stay tuned and wait for more videos. Thank you.